So let's go back to the functions exam paper questions that I gave you to practice with. And the fourth question, or page 4 of the questions, had two functions, and looking at them here you can see that this is an exponential function. So straight away we expect that its graph is going to be something like this, okay, kind of sloping up really quickly. And this is a quadratic, and the first thing I do with that is rearrange it so that we have the x squared term first. And remember, when you're rearranging, you want to keep the sign with whatever term that you have. So the minus 3 stays with the x squared. It's a plus 9x and a minus 1. So that's a negative x squared, and that means that we expect it to be n-shaped. So it's good to have an idea of what shape the graphs are going to be before you're even drawing them. You know, you will get points for having the correct shape even if you couldn't do anything else. So if you're really badly stuck for time, this is something that you could put down straight away. Now then they ask us to complete the table below and use it to draw the graphs of f and g. So of course they have this notation here, f such that x is mapped onto. So we just want to rewrite that as f of x equals 2 to the power of x, and this is g such that x is mapped onto, and we'll just write that as g of x equal to, and we're going to write it in this format here, minus 3x squared plus 9x minus 1. So that's what we're filling into when we're substituting in these x values here. So remember, these are our y values. The function, the output is always the y value. So just use your calculator for each of them in turn. 2 to the power of 0, anything to the power of 0 is 1. Then it's 2 to the power of a half, or 0.5. The light's not very good here. And we get 1.41. So that's the square root of 2. We'll just go to 2 decimal places, 1.41. We mightn't even use that. 2 to the power of 1, of course, is 2. 2 to the power of 1.5, 1.5, 2.83. 2 to the power of 2 is 4. You know, when you know the answer, you don't even have to take the time to put it into your calculator. 2 to the power of 2.5 is 5.66. And 2 to the power of 3 is 8. So that's my f of x done. And then I'm doing my quadratic. And we mightn't get the full n shape out here because we have a limited number of answers. Let's do them anyway. So if we fill in 0 for x, we have negative 3 by 0 squared plus 9 by 0 minus 1. It's going to give us our y-intercept there, minus 1. That's the constant term. Minus 1 for that. And then we're putting in 0.5, both places where x was. And we get 11 over 4, 2.75. Fill in 1 for x. I'm actually going to do the 1.5 first, because I already have the 0.5 filled in, and that is 5.75 here. Now I'll go back and do the 1. It's only about trying to get a bit quicker with the calculator. 5. You can see it's increasing the whole time here, so we're only getting part of the graph. 2. And we have 5. So it's symmetrical. Here's our maximum point here. 2.5. Going to be coming back down again. And we have 2.75. Because this is a quadratic, we know it's symmetrical. We know this should be minus 1. And again, if you were stuck for time, that's something you could just go ahead and fill in. So we get minus 1. So those are my points, and I'm going to plot them. I'm going to do my quadratic first, just because I have the purple pen in my hand. So when x is 0, y is minus 1. We know the y-intercept there. Excuse me. When x is 0.5, y is 2.75. When x is 1, y is 5. When x is 1.5, x is 5.75. When x is 2, y is 5. When x is 2.5, y is 2.75. So we have our symmetry. And when x is 3, we're back down to -1 again. So we want to have a smooth curve here. The important thing is that you wouldn't use a ruler. We know what shape a quadratic should have, our N shape here. So there we go. Okay, and then our exponential function, y-intercept at 1, like all exponential functions. At a half, we're at 1.41, so nearly at 1.5. At 1, we're up at 2. 1.5, 2.83. 2, we're up at 4. 2.5, 5.66. And 3, we're up at 8. So there's our exponential function, starting off slow and then growing really fast. Kind of a ski slope. A bit of a mistake there. Be as accurate as you can, but don't spend loads of time on getting these out. Okay, that's close enough. I'll get me my marks. Now, they've asked us to use our graphs to estimate the values of x for which they are equal to 0. So what they're saying here is, when is this plus this equal to 0? So they're looking for the output of the two graphs together equal to 0. So the y values equal to 0. Now, the interesting thing is, we know that this 2x is equal to 0 when x is equal to 1. We're looking at our y-intercept. So output equal to 0, our y-intercept. And we've got this part equal to 0. So I'm just going to say g of x equal to 0 when x is equal to equal to 0. Sorry, I wrote down the wrong thing there. Not our y-intercept. Our x-intercept is what we're looking for. I apologize. So we're looking for the x-intercept. Okay, so 2x is equal to 0. Never. It never intersects. So along here, it never intersects. So what are we doing? We're looking for this one equal to 0, roughly here and here. Okay, so what they're asking for here though is when I add them together. So what we notice is if I add these 2 points here, it's a difficult question. If we add these two together, it will go through the x-axis there. So when x is equal to let's say 0.1 there and 2.7 there. But when I add them together, add the graphs together. So I can't solve this using algebra because they've asked me to use my graphs. So add my graphs together and we can see that it happens at x equals 0. So they're talking about the origin. X equals 0, y equals 0. When we add the graphs together, we got the point 0, 0. Okay, so how do I write that down as an answer? How do I show it on my graph? We just do a little arrow to there. We add the graphs together. And we can see that x equal to 0 gives y equal to 0 as well. Is there any other place where, when we add them together, they might cancel each other out as well? Where the y values have the same, where the y values are the same but opposite? There's nowhere else that I can see on this graph in this domain that we have here. So the other place where we've got a negative value for this is at -1 here, but that's at 8, so they're not going to cancel each other out. They're not going to cross the x-axis there. So the reason here is that we have 1 and -1. So the two outputs, I want to give an explanation here. It's a very difficult question for ordinary level. So because the y values are the same but opposite, so they cancel each other out. Okay, so that's the best explanation I can give for the answer that we have there, is that we've got 1 and -1 for my y values, meaning that they'll cancel each other out and give me 0 for an output. So the origin is where the two graphs added together would cross the x-axis. Do let me know if that's a bit confusing. Maybe the explanation there is a bit confusing. I can go over it again if you want. Okay, let's look at part C. Let k be a number such that 2 to the power of k is equal to 6. So again, they're telling me the output. I'm looking for the value where y is equal to 6. So if I come up here onto my graph, y is equal to 6, then if I draw a line going straight across here, like this, they want us to estimate g of k. So first of all, I need to find k. Okay, so what am I talking about there? They want me to find, so find the x value when 2 to the power of k is equal to 6. They want me to find k. So if I come across here, remember that this is my f of x, and this is my g of x. So it crosses the axis here, or crosses the graph here. Sorry, I've gone out of shot. Crosses the graph here. So there is k. Now, they didn't exactly ask me to find k. So k is approximately 2.6. Let's write it down anyway because it's useful. So they want me to find g of 2.6. So if I look at where it crosses this graph here, and I need to find the y value that matches that, I bring my graph back over here, and it's approximately 2.1. So using my graph, 2.1. So g of k g of k should be approximately 2.1. So what did I do there? They wanted me to use the input for this graph, the input for my exponential, and use the same input to find the matching output for my quadratic. Confusing, okay. So let's just go over those steps again because that's a confusing question. They said k is a number such that the output of my exponential function is 6. So I come up to my y-axis and I draw a straight line across from 6. Then I find where it intersects my exponential and I drop down to the x-axis to find what that input was, what that value for k was. Then using that value for k, I put it into my quadratic. I could have done this using algebra, but they suggested that I use my graph and they didn't give me a lot of space. So then I come back up to my quadratic function and I come across to find out what that output would be. So remember, my x-axis is my input and I have two different outputs. That's the output for my exponential function and that's the output for my quadratic function. Now, I spent a lot of time going through. That is a question that should only take about 12.5 minutes because it's a 25-mark question, but most of the time there was going over the explanation. So this is something you'd want to be doing quite quickly, getting your graph down on paper and then using your ruler, going across, showing the matching inputs and outputs. This question here, very, very difficult, adding the two graphs together. Not something I would have expected to see on the ordinary level paper, but if you even indicated that you understood that asking for the output equal to 0 meant you were looking for where it crosses the x-axis, you should get your partial credit for a question like that. Okay, thank you.